A thin wire of length capital L and uniform linear mass density rho is bent into a circular loop with center at O as shown. The moment of inertia of the loop about the axis x prime s. Acha. So in question 7, the axis of rotation is similar to the one that I have asked you to try in question 6. Okay, similar to that. Okay, so I have a thin wire of length L. It is bent into a circular loop. So if the radius of the circular loop is r, then L will be 2 pi or r will be L upon 2 pi. Okay. Uniform linear mass density rho. Okay, so rho is uniform linear mass density. Linear mass density. So what will be capital M? Capital M will be density into length. Okay, capital M will be density into length. Okay, now we have to find the moment of inertia of the loop about the axis x prime. So first of all, we have to find it about its centroidal axis. Okay, I through O perpendicular to plane of ring, that is mr squared. For ring it is mr squared, but what is r? L upon 2 pi, so ml squared upon 4 pi squared. Okay, now we don't want that, so we will say now by perpendicular axis theorem, by perpendicular axis theorem. Now let me call it I1. I1 will be half of this. Now why half of this, you might ask? Look, according to that perpendicular axis theorem, this moment of inertia is actually addition of moments of inertia about these two axes which are perpendicular to each other. Correct? Say this is x and this is y, then Ixx plus Iyy is equal to Izz. Correct? So each one of them, Ixx and Iyy, will be half of the main. Okay, I through O perpendicular to the plane of the ring. Correct? So I1 will be half of that. Now we have to use parallel axis theorem. I required will be ml squared upon 8 pi squared plus m into r squared, again r squared. Why r squared? Because that is the distance between the axis of rotation and the corresponding axis of rotation through the center of mass. Okay, r squared, but what is r? L upon 2 pi. Okay, so what will be that? 3 ml squared upon 8 pi squared. This is 1 upon it, and that will be 2 by 8. So 3 by 8 fraction. Oh, I think I have everywhere written, I should have written the 4 squared, right? Wait. Oh, 3 ml squared upon 8 pi squared. Okay, m is equal to rho. Sorry, m is equal to rho. 3 rho L cube upon 8 pi squared. Yeah, 3 rho L cube upon 8 pi squared. Well, I was a bit surprised because I did not see L squared anywhere. But then I realized that mass is also rho into L. Okay, mass is rho into L, so that is option D. This ring's moment of inertia about the blue axis is just mr squared, correct?
Yeah.
Now, do you agree that moment of inertia of disk about any of its diameter will be same due to symmetry? So if this in GeoGebra, red is the x-axis and green is the y-axis. So you agree that Ix and Iy are same.
Yeah.
But you also agree that Ix plus Iy is Iz according to perpendicular axis theorem.
Yeah.
So each of those red and green will be half of what you said for blue. That is mr squared. Hence that is mr squared by 2.
Oh, okay, got it.
And then you just take a line. Okay, you take let's say y equal to root 5. And you take its intersection with z equal to 0. Okay, now if you take it about the line that I have shown or which they want, how is the orientation? Okay, it's about. So it's something like this. Got it? So to shift this red width by r, so plus mr square. Got it? And that's this.
Yeah, I got that.
Yeah, very good.